Hello, this is Mr. Collier, and today we're doing counting principles, which is leading up to probability later. Okay, let's take a look at this first example. I have 5 cards labeled A, B, C, D, and E. How many ways can I arrange 2 of them so that they're placed in a line? Okay, so you can have first letter A, then B, A, then C, A, D, A, E. So 4 possibilities starting with A. And with B, of course, you got 4 more possibilities. So then you can start with C, D, and E. Altogether, you're going to have 4 by 5 possibilities, so there's 20 ways to do this. Another way to think about it is there's 5 possibilities to choose your first letter, and then 4 ways to choose the second one. So in total, there are 20 ways to do it. Okay, now part B, how many ways to place 5 of them in a line? Well, you can do, we can do it this way right here. Look, you can have 5 ways to do the first one, to pick the first letter. There's 4 left over for the second letter, then 3, then 2, and then the last one is left over. So that is equal to 5 factorial, which equals 120. Okay, so if the arrangement matters, these are called permutations. Okay, if the arrangement matters, these are called permutations. And if it's all of them, you can just do factorial. But notice this here is sort of like 5 factorial, but with a 3, 2, 1 gun. So it's the same as 5 factorial divided by 3 factorial, which leads us to the general permutation formula. If you got n objects and you want to permute them in r ways, you can do the n factorial, like in this example, and this is like n minus r factorial. Okay, if you have n objects and you want to arrange r of them, you do n factorial over n minus r factorial. So this is a formula that for permutations, but you don't generally need it. You can just do this method right here. Okay. Okay, next let's look at these examples. A 3-digit number is formed by selecting 3 cards from 10, labeled 0 to 9, so that's 10 cards. How many ways can this be done if the same number can be used more than once? So that means there's 10 possibilities for the first one, 10 for the second one, 10 for the third one. This is 10 cubed or 1,000. Okay, so if you got a 3-digit bicycle combination, this is the number of combinations. If each number can be used only once, then you got 10 choices for the first one, 9 choices for the second one, and 8 choices for the last one. So that's 720. Okay, let's look at the next example here. If the numbers can be used only once, how many numbers greater than 700 can be formed? Okay, greater than 700 means the first digit has to be 8, 9, or 7, 8, or 9. So that is 3 possibilities for the first one. You already used one, so the second digit's got 9 possibilities, and then the last digit has 8 possibilities. Okay? So that all equals 216. How many odd numbers greater than 700 can be formed? Okay, if we want to look at the odd numbers, well, you got a couple of situations. We could have odd first digit and odd or even first digit. Okay, that matters because we want the last digit to be odd. So it really matters what first digit you choose. Okay, if your first digit is odd, we could have a 7 or a 9. So there's 2 possibilities for the first digit. For the second digit, now let's look at the last digit first, actually. You've got, that means for your last digit, you have 4 possibilities because you already used 1 odd digit, right? And for the middle digit, you have actually 8 possibilities because that could be even or odd, and 2 of them have already been used up. So this equals 64 possibilities. If the first digit is even, in other words, it's an 8, there's 1 choice for the first digit. For the last digit, you have 5 choices, and for the middle one, again, you have 8. So that's that's 40. So the total is actually 104 possibilities. Okay, in the next example, okay, we have 6 books, 2 which are green. So 2 green, 4 red. How many ways can I arrange them on a shelf if there are no restrictions? So there's 6 books, so that's 6 factorial, which equals 6 times 5 all the way down to 1, which equals 720. 1 red book must be at each end. Okay, so there's 2 red books, so we got a red on each end, then we've got 4 in the middle, and then we've got a red one. Okay, so how many ways are there to do that then? There are 4 possibilities to choose the very first one. There are 3 possibilities to choose the last one, and then you can choose the middle, and there's 4, 3, 2, 1 possibilities for the middle. So we kind of separate this, right? There's 4 factorial ways to pick the 4 leftovers, and there's 4 ways to pick the first one and 3 ways to pick the last one. Okay, the red books must not all be together. Okay, so there's a couple ways to think about this. There's a couple ways to think about the red books need to be together. So let me separate this. So you can have red, 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 green, green, or you can have green, one green on the front, one green on the back, or you can have green, green on the front, right? What you can do for these kind of questions is you think of this as one thing. It's all the reds, okay? Think of that as all the reds. So this is called RA or something. And then GG. So there's actually 3, G1 and G2 I'll call them, because they're 2 different green ones. So it's really like 3 objects. Think of these books as all glued together as one. So there's really 3 objects. So there's 3 factorial ways to arrange these 3 objects, including this big clump of 4 books. And within that clump of 4 books, there's 4 factorial ways to arrange them. So the answer is 144 ways. Okay. Then part D. In part D, the red books must not all be together. So you just need to do the total number of ways, if you think about it, minus 144. So often doing this kind of thing is a lot easier than doing it the other way. So sometimes figuring out the number of ways something cannot happen is to do the total minus the number of ways something can happen. Okay, so this is a useful tactic sometimes when solving these problems. If I put books on the shelf at random, what's the probability the red books are together? So that would be a result from part C. The red books must be together. That's 144 ways divided by the total, which actually equals 0.2 or 20%. Okay, now for the final example, there's many ways to do this one, but there's a really neat trick. If I now have 3 green and 4 red books, how many ways can they be placed on the shelf so that no green books are together? So what we're going to do here for this one, there's a lot of ways to do it. Some of them are very inefficient, but the gap method is very efficient. For the gap method, we don't want the green ones together. We want, none of the green ones together. So let's place the red ones here first. So there's 4 red ones. Now the green ones can go to the left or the right of all the red ones. So I call these gaps. Okay, they can go in any of these locations. But you can't have 2 in one spot. So this problem is equivalent to taking your 3 green books and placing them in these gaps. They have to go somewhere in these 5 gaps. Okay? So there are 5 choose 3 ways to pick the gaps. Okay? Then there are 3 factorial ways to arrange 3 green books and 4 factorial ways to arrange the red books. So all that works out to 1,440 ways.